Section 2.2 Types of Cryptography. There are many different types of cryptography. Some types used in the past were hidden message. For example, the messenger could swallow the message, or hide it in their boot heel or saddle, or simply memorize it. It was common in ancient times to have a messenger memorize a message phonetically in a language they did not understand. Secret method, such as the Caesar cipher, where each letter of the alphabet is replaced by the letter 3 places later. That is, A becomes D, B becomes E, C becomes F, and so forth. Disguised message, where the message is made to look like something else, such as a design in the messenger's garments. Invisible message, such as microdots or invisible inks that become visible when heated or exposed to acid. Misdirection, for example, where the signature or the shape and color of the paper are the true messages, and everything else is distraction or disinformation. Collectively, all methods for hiding a message are called steganography, first described in the 1499 book Steganographia by Benedictine abbot Johannes Trithemius, born Johannes Heidenberg. Trithemius's book is itself a form of steganography, since it is disguised as a book of magic. Some of these steganographic methods have modern counterparts. For example, a message can be concealed in a JPEG image file by using only the low-order bits of each pixel. Another example is to use a random number generator to pick certain bits in each byte of a file. The chosen bits contain the message, and the remaining bits can be random gibberish. Before describing modern ciphers, let me introduce a useful shorthand. A message is sent from a sender to a receiver, and the purpose of encryption is to keep some enemy from reading the message. For brevity, I call the sender Sandra, the intended receiver Reva, and the enemy Emily. This is more natural than Alice, Bob and Carol, isn't it? Usually, Sandra enciphers the message at her location before sending it to Reva. The message may be sent by any means: letter, telephone, internet, shortwave radio, Aldis lamp, microburst, telegraph, fiber optic cable, semaphore, quantum entanglement, or even smoke signals, if there is a direct line of sight. To make this picture more complete, the cipher may require a key as well as the plain text, and there may be an enemy listening in. Here is a fuller image. Modern ciphers generally fall into 3 broad categories: secret key, public key, and personal key. Their main distinguishing features are as follows. Secret key. Sandra has a secret key which she uses to encipher messages. Reva has a corresponding secret key which she uses to decipher those messages. This may be the same key or an inverse key. Usually Sandra controls the key. When Sandra changes the key, she must send the new key, or its inverse, to Reva. This is the standard paradigm of classical cryptography. Public key. Reva has a public encryption key, which she makes known to everyone. Whenever Sandra wants to send Reva a message, she enciphers it using Reva's public key. Reva also has a secret decryption key, known only to herself, which she can use to decipher the messages that she receives. To make this scheme work, it is essential that nobody else can compute this secret key from the public information. The dominant public key method is the RSA algorithm, invented by Ronald Rivest, Adi Shamir, and Len Adelman in about 1975. Personal key. Sandra and Reva each have a personal key they share with nobody, not even one another. Since no keys are ever transmitted or shared, personal key cryptography is sometimes called keyless cryptography. Here is how it works. Pass 1. Sandra enciphers the message with her personal key and sends the enciphered message to Reva. Pass 2. Riva enciphers that message with her personal key and sends this doubly enciphered message back to Sandra. Pass 3. Sandra deciphers that message using her personal key and sends this back to Riva. This message is now enciphered only with Riva's key, which she uses to read the message. The tricky part here is that Sandra's encryption and Riva's encryption need to commute. That is, they must produce the same result regardless of whether Sandra encrypts first or Riva encrypts first. Symbolically, we express this as SRM equals RSM, where M is the message and S and R are Sandra's and Riva's encryptions. The advantage of personal key cryptography is that anybody can communicate securely with anybody else without having to prearrange any keys or transmit any keys, so there is no possibility of a key being intercepted. Personal key cryptography is also called the 3-pass protocol. A protocol is just a sequence of steps used for some purpose such as transmitting a message. In other words, a protocol is an algorithm. The basic idea for the 3-pass protocol was invented by Adi Shamir in about 1975, and the specific method I present in this book is my own. Section 2.3. Symmetric versus asymmetric cryptography. Many books state that cryptography can be divided into two types, symmetric and asymmetric ciphers. The idea is that in secret key cryptography, Sandra and Riva use the same key to both encrypt and decrypt the message, while in public key cryptography, Sandra uses one key while Riva uses its inverse. This dichotomy overlooks personal key cryptography, which is neither symmetric nor asymmetric, as well as the various classical methods described at the start of section 2.2. Moreover, the symmetric-asymmetric classification is not always accurate. In section 15.1, I describe the Hill cipher, a secret key method where encryption consists of multiplying the message by the key, and decryption consists of multiplying by an inverse key, just like public key cryptography. Categorizing a cipher as either symmetric or asymmetric is not particularly useful. It fails to capture the essential difference between secret key and public key cryptography, namely that in secret key cryptography all of the keys are kept secret, while in public key cryptography each party keeps one key secret and makes one key public and available to everyone. Public key cryptography and personal key cryptography both came out around 1975. Public key cryptography fired the imagination, so secret key and personal key methods have received scant attention since that time. Public key cryptography is fully covered in many books. This book focuses primarily on secret key cryptography, the mainstay and bedrock of cryptography. Section 2.4. Block ciphers versus stream ciphers. Another classification is to divide ciphers into block ciphers and stream ciphers. Block ciphers operate on blocks of characters in the message, say blocks of 5 characters. Usually all of the blocks are the same size, and the same key is used for every block. Stream ciphers operate on one character of the message at a time. Each character has its own key, called the character key, typically taken from a larger key called the message key. In older stream ciphers, the message key was repeated. For example, if the message key size was 10 characters, then the first key character would be used to encipher message characters 1, 11, 21, 31 of the message. The second key character would encipher message characters 2, 12, 22, 32, and so forth. Ciphers using regularly repeating keys are called periodic. In newer stream ciphers, the message key is usually as long as the message itself and is called the key stream. This aperiodic or non-periodic style of enciphering is called the one-time pad. In Chapter 13, there are discussions of how key streams can be generated. The block/stream classification is not exclusive. There are hybrid ciphers where the message is broken up into blocks, but different blocks are enciphered with different keys, so the cipher operates on a stream of blocks rather than a stream of characters.